The third way of looking at a relationship and determining whether or not it's linear or quadratic is actually by looking at its equation. So for example, if you are given two graphs, and you can look at the actual graph itself, you know, if it looks like a line, it's a linear relationship. If it looks like a U, it's a parabola, and therefore a quadratic relationship. If you're given a table of values, which is the second way of determining, if your first differences are the same, it's linear. If your second differences are the same, then it's a quadratic relationship. But what if you're just given the equations? And I'm going to take this and actually do it a little bit backwards. There is a specific feature or property of the equation that allows you to identify the type of relation. Okay? And so what you want to look at here is always for the highest exponent. So the highest exponent that's in an equation will tell you whether or not the relationship is going to be linear or quadratic. Okay? And again, the exponent is always kind of the tiny little expression that, or the tiny little number that's to the upper right of a variable. Okay? So for example, if you have just an x that doesn't look like it has an exponent, what that actually means is x to the exponent 1. If, however, you have an x squared, that means x squared. Okay? And what's really cool about this is that the number value of the exponent is going to actually determine which differences are the same. So for example, when you have just an x value, then it means x to the exponent 1. And because it's x to the exponent 1, that means that the first differences are the same. So first differences are the same. We know that when first differences are the same, it equals linear. Okay, it's a linear relationship. If the x value, or if the exponent on the, if the highest exponent in the equation is a 2, then that means that the second differences are the same. Okay, and we've already talked about how if the second differences are the same, then it's quadratic. Okay, so you always have to look at the highest exponent that's in the equation, and that will determine for you whether or not it's a linear or quadratic relationship. So let's take a look and use this knowledge and apply it up here. So here we have y is equal to x squared minus 5. So the first thing you want to ask yourself is, what is the highest exponent out there? Okay, and again, if there is no exponent, then it's not a linear or a quadratic relationship. Okay. So for example, if you have, the highest exponent is 3 or 4 or 7, then it's neither a linear nor quadratic relationship. So if we are going to determine whether or not these four examples here are linear or quadratic, we have to figure out, well, what's the highest exponent? Okay, and so in the first example, where we have y is equal to x squared minus 5, the highest exponent is actually 2. Okay, and because of that, this is therefore a quadratic relationship. Just to the right here, we have x plus y minus 5 equals 0. Okay, so what therefore is the highest exponent in this particular equation? It doesn't look like there are any exponents written here, but what that actually means is that there's an exponent 1 and another exponent 1. Okay, so 1 is the highest exponent. And therefore, since 1's the highest exponent, that means the first differences are the same, and it's linear. Again, if we shift to the right one, we've got y is equal to x squared. Okay, well, if it's y is equal to x squared, the highest exponent is 2, and so this is quadratic. Okay, in fact, y is equal to x squared is what's known as the parent form of a quadratic relationship. We'll talk about that in the next unit. And again, we've got y is equal to negative 5x plus 2. So again, what's the highest exponent? Well, it doesn't look like there are any exponents. However, so when there's no exponent written, then the exponent must therefore be a 1. Okay, and so therefore the highest exponent is 1, making this equation linear. Okay, so working with just the equation, you can determine whether it's quadratic, linear, or neither one by again looking at the value of the highest exponent in that particular equation.